Yeah, good morning. Today we shall discuss a few more SQL queries. So consider the database described over here having five tables. So the five tables include student, course, enroll, book adoption, and textbook. So look at the attributes that are present in these tables. Student is having SSN, name of the student, major, birth date. Course is having course number, course name, and department. Enroll is having SSN, which means it is a student SSN, course number, quarter, and grade. Book adoption is having course number, quarter, book ISBN. And text is having the attributes book ISBN, book title, publisher, and author. By looking at the attributes, so we can make a note here how one table is related to other tables. So here so student table is related to this enroll table. So this relationship is through the attribute SSN, which is common. Then uh, course course and enroll are related through, so course over here, course, and again this enroll table. So these are related to using course number attribute. Then book adoption is related to enrollment as well as this course through course number, right? And finally we have the textbook related to book adoption using the attribute that is book ISBN. So it is these attributes which we will be using when we want to join these tables. Now let us look at the first query. List the number of courses taken by all students named John Smith in winter 2009. That is quarter is equal to W09. So this is the query. So we have to list all the courses that are taken by a student, John Smith, in winter. So winter 2019 is represented using the quarter whose value is W09. So student name is present in student table, whereas the courses detail is present in the course table. And in order to establish a relationship between the student and the course, we have to use the table enroll. So three tables are required. Okay. Here, whether we need the course name and department also, or just course number is sufficient. So that we need to decide. So if course number is sufficient, then we can do the task with only two tables. If we need course name also, then three tables are required. But in the question, list the number of courses taken. So here the only thing that matters is the number of courses enrolled and not about the courses that are enrolled. So just a number is sufficient. So when we don't need a course name, so we will just combine two tables. So the tables that we need to combine is student and enrollment. So we'll write a query like this. So select So what are the things that we need is, so about a student we can use the SSN. So that student table, let us call it as s dot ssn, then s dot name, and then we need the number of courses. So how to get the number of courses? So we shall leave it. Then here from which table? So student table alias yes, and then the enroll table. So enroll table, let us give the alias e. Then we have to join these two tables using s dot ssn is equal to e dot ssn. So now these two tables are joined. But in the query, one more condition is given, that the student named John Smith. So which means a name also we must include. So that condition we shall write over here. So s dot name is equal to John Smith. So this completes the condition. So here we will get only SSN and name, but in the question it is asked is the count of how many courses are enrolled. So for that, what we have to do is we have to group. So group the result based on the SSN, because here in the question it is mentioned that name should be John Smith, but there may be more than one student whose name is John Smith. So if more than one student are present, then we have to group the result based on the SSN, and then we have to extract the count. So what we will do is we will group by s dot ssn. So in Oracle, if we are running, then we have to include the s dot name also. Otherwise, in many other database packages, this grouping by of name is not required. So once we group it, then we can get the count by using the aggregate function count. So count of, what we need to count here? Count the number of courses. So number of courses means it is a course number which we are counting. So that is there in the enroll table. So that is e dot course number. So this is a one way of doing it. Or in place of this e dot course number, here we can also write a star, count of star. So count of star includes the number of rows in that particular group. And here the number of rows in a group indicate the number of courses taken by a student. So in two ways, so we can specify over here, either count of star or count of e dot course number. So this would be have been a safest way when you are writing the queries in exams, because by looking at it only, the evaluator will come to know that you are counting the course number, so which is according to the query given. So then the second one, produce a list of textbooks including course number, book ISBN, book title for courses offered by CS department that have used more than 2 books. So let us clear this. So list of books we need to extract for the courses that are offered by the CS department. That is the first condition. And the second condition is that have used more than 2 books. So which means we need to get the list of courses from the CS department that are using more than two books. So in which table we will get this particular information? So department information is present in this course table, where we'll have department, and then the book adoption table we need to get. In book adoption table, so we have course number and the book ISBN, and then book ISBN can be linked with textbook. So three tables are required here, but here what matters is the second condition that is important, more than two books. So this condition when we want to apply, so then we need to be careful. So how to solve this particular query? So we can join these three tables, so that is not a matter, based on the course number and book ISBN. But to extract only those having more than two books is important. So if I want to simply represent the solution in a C programming terminology, for each book adopted by CS department, we can verify whether it is adopting more than two. So if it is adopting more than two, then we can extract it. So just like that. So for each book in CS department, can we extract this detail? Yes. So what we can do is, for each book, so we can iterate here. So we can check number of books for this particular course. Sorry, for each course. This is for each course in CS, we can check the number of books adopted by that particular course. So if this is greater than 2, then we can print it or we can extract it. So let us assume this is n. If n is more than 2, so it is greater than 2, then select the course. So this is the solution in normal programming terminology for you to understand. So if you observe here, for each book, for each course, we are performing some task. So which means this will be a nested query in SQL, and the course is being used in the inside also, because the iterator will iterate over each course. So the current iteration course is utilized to extract. So which means it will be a correlated nested query. So we'll have correlated nested query. So we shall um, write the query. So let us start the query. So select. So what are the attributes we need? So we can mention here. So we need all the details from textbook table, that is okay. So we need ISBN, book title. So course number we need. So course number, let us extract it from table C. So C dot course number, comma, book ISBN. So let us extract it from book adoption table. So B dot, and these attributes which are common in many tables which we will be joining can be extracted from any tables. So and title is present in textbook table. So T dot book title. So T dot book title. So that become our select statement. And then next we shall write from. So what are the tables we need? So course. So let us call this as C. Then book adoption. So let us call this as B. And then we need text table. So let us call this as T. So and then we need to um, combine these two tables. So three tables. So C dot C and book adoption can be combined on course number. So C dot course number is equal to B dot course number, and book adoption and textbook can be combined on book ISBN. So B dot book ISBN is equal to T dot book ISBN. So this joined these three tables. So course and book adoption on course number, book and text on this. So now only this three tables are joined. So this is the outer for loop. Now what we have to do is we have to write the inner query. So for that, what we have to do is we'll put and, that is one more condition we have to put, because for on each course we need to check whether it is adopted two books or not. And again, one more condition is given in the query that the department should be CS. So that condition also we need to mention. So that is mentioned using C dot DEPT is equal to CS. So this query will extract all the course numbers and their books and titles of CS department. And next, the condition of the inner query, that whether it has used more than two books, so that has to be verified. So, so for that we have to write the inner query. So we will write the inner query using exists, and we will write the keyword exists. So which means for each course we will check whether it exists in the inner query. So in the inner query, we'll check how many books it is adopting. So how to check how many books it is adopting? So that is based on the course and book adoption tables only. Okay. So select. So here exists is there. So it doesn't matter which attribute we select. So you can just write C dot. So C dot course number from So since this is a correlated nested query, so we will not be using the course table over here. We'll utilize the course table from the outside itself. So then only it will become uh, correlated nested query. So here we will be writing the book adoption table. So another instance of book adoption is required for us. So book adoption. So let us give the name B1, right? Then what we have to do is we have to uh, check whether how many books it has adopted. So for that what we have to do, we have to group it. So group it, then we have to count it, how many are there. So here, so group by course number c dot. So it is based on the course number we are grouping. So here actually when we write only select and from, then only we will get the number of books, but we need greater than 2. That condition also has to be added. So for that particular purpose, so we are writing group by, and then we'll be writing having count of star greater than 2, and here the inner query ends. So now what happens for each course, so it will check whether it is existing in the inner query. So which means this should return more than one row, one or more rows. So if 0 rows are returned, then the exist will return false. So this is one way of writing this particular query using the exists keyword. So other alternate is to just extract the um, number of books, and then we will put the greater than 2 condition outside itself. So how we can do it? So for that purpose, so whatever we have written over here exists, so this we can change. So how we can change it? So I will just erase a few parts over here. By retaining the select and from. Okay. So this part will, so this part will give us how many books are there. So again here course number is not required for us. We select. Okay. So in the previous condition also where clause was missing, so we need to join these two, where c dot course number is equal to b1 dot course number. So this we need to add for the previous case also, where we used grow exist class. So here this, that's it. Okay. And this has combined the course and the book adoption, and here we can extract the count of star. So this will give how many rows are there here. So if this value is greater than 2, so here we can write over here. So two ways we can solve this. So inner query, what does it do? For each course, its book adoption table gets joined, and then we'll extract. So how many rows have been joined for that particular inner query. So if that is greater than 2, then for this course number, the condition will become true and it gets selected. So next, let us go to the next one. So that is list any department that has all its adopted books published by Pearson Publishing. So which means we must extract the department which has adopted all the books from a particular publisher. So when we have a condition like all and other things, so what we have to do is we have to use the uh, exists or in clauses. So this query we will solve in the reverse. So first we will we'll join all the tables and then we will verify whether a department has adopted any book which is not published by the Pearson. Okay. So that way, in the reverse way, so we will solve this. So the query will look like this. Select, so we can write the, okay, we just need the department over here. So that is present in the course table. So C dot department from, so the tables which we need to join is course C, then book adoption, B, let us call it as B, and then text T. Then in the where clause we shall join these three tables using C dot course number is equal to B dot course number, and another thing is B dot book ISBN is equal to, so the last condition is T dot book ISBN. Okay, so all the three tables are joined now. So in order to join three tables, so we need two conditions at least. Okay, so next we need to check whether this particular department is having a book outside the publisher, that is Pierce, and that condition can be added over here. And T dot publisher is not equal to Pearson. Okay, so this will extract all the departments whose publisher is not Pearson. Here there may be a repetition of this particular department. So in order to avoid the repetition in the result, for example, our result may look like this: EC mechanical, again EC, again EC, like that. If there are three courses which has not adopted, then all those things will appear. So in order to avoid the repetition of department in the result, so what we can do is, so we can have a distinct keyword mentioned over here. So that keyword we can mention over here, that is distinct. So here we can write it. So select distinct department from course, book adoption, and text. Course number is equal to book dot course number, and book dot ISBN is equal to T dot book ISBN, and T dot publisher is not equal to Pearson. So this is a simple result or simple query that we can write to extract department which is has adopted all its publisher from Pearson. So these are the departments that have um, adopted books which are not from Pearson. But actually in the question what we need is the department that has adopted all the books by Pearson. So we need to do some set operation. So set operation we can perform like this. So all departments on one side minus departments uh, having non-Pearson books. So in the query what we have written above, we are extracting the second part, that is the departments which are having non-Pearson textbooks. So next thing what we do is, so just get all the departments using select DEPTs from course. So let us call this as C1, so it doesn't matter. This is the first part where we extract all the department. Then we will perform minus. Again, one department may be present many number of times. So again here we will put the distinct. Okay. So select distinct departments from course minus, here we will write this particular query, whatever we have written over here. Okay. So this query will appear here. So this completes the result. So select all the departments minus the departments that are having a non-Pearson. If any one non-Pearson book is used, then the department will be extracted here and that will appear in the minus part. So only three queries are asked in this particular question. So next let us move on to the next database, this one. Okay. So movie database, so we shall quickly solve these four queries. So movie title, director, movie year, rating, actor, actor age, acts in the actor, title, director and director age. So these are the four tables that are present over here. So let us look at the first query. Find movies made by Hansen after 1997. So movies made by means, so he must be the director, and here the director name is given after 1997. So year is also given over here. So we must in order to get the director name, so we must use the director table, and in order to get the year, we can use the movie table. So we can write the query like this. So what we need to do is we must join the movie and director table. So select. So what are the attributes we need? Find movies. So movies means it is the title we need. So title. So again let us use the alias m dot title. So from um, movie table, so let us give the alias m to this, and directors d, and to join this we will put a where clause where, so m dot director is equal to d dot director. And additionally, few other condition are mentioned in the queries. That is the name of the director. So director is equal to, so again we'll put it in d dot director is equal to, so Hansen, and one more condition is added that it should be after 1997. So that is present in movie table, that is m dot m year, so it is greater than 1997. So this will get all the titles of the movies directed by this person after 1997. Okay. So this is the required result. So next, let us move on to the next query. The second one, find all actors and directors. So all actors we need and all directors we need. So the name. So we can find the solution to this query in two ways. That is how we want the result. Whether we want the result to be in a single column where it contain both actor and director, or we want the result in two columns. So actor and director. So for each actor, the director will be present over here. So I mean the movie acted by this actor, uh, its director will be presented in the next row. Or what we can do is we can just put the actors, then we can find the directors in a single column. So if you want a single column, then we have to use the union operator, or if we want two columns, then we want to use the join operations. So let us look at the first case where we want it in a single column, then we have to use the union. So what we'll do is select actor from actor table. Okay, so this will get all the actors. So again, we can put the distinct condition over here. So select the distinct actor from actor table, and then perform the union with director. So select distinct director from directors table. So this query will give the result in the single column format. So where it will list all the actor names, then below it will give the all the director names. So this is first way. And second way, if you want it in multiple columns, so then we need a mechanism where we can join the actor and the director table. So for that, we need to first join actor and acts, then acts and movie, then movie and director. So all the four tables needs to be combined together, and then we need to extract the actor and directors. So that is the solution. So if we want it in two columns, so how? So select, um, let us give the name a dot actor, comma d dot director from, so include all the four tables over here. Let us call movie as M, actors as A, uh, acts as AC, and then uh, director as D. Where, so now join all of them. Where M dot title means we can join is equal to, title means acts means AC. So AC dot title, and AC dot actor is equal to actor dot actor. And how to join the director? So it's based on again movie. So m dot uh, director is equal to d dot director. So in order to join four tables, we need three conditions. So by this, we can extract actor and director details of all. So this query, we want it to be two columns. So the simple one, if you want it in a single column. So next, third one, find Cohen's movie with McDormand. So here, both of them are actors. Both of them should act in a single movie. So those movie names, so we must extract. So here both the names are given over here. So we must extract a movie name such that both of them have acted. So a simple query for this would look like this. From the first we must join the actor and acts table, and then we must put a condition that only those movies we must extract where the Cohen and McDormand have acted. So again, for this particular query, we can utilize the union operator, or sorry, intersection operator, where what we can do is first we can extract the movies acted by Cohen like this. Cohen's movie we will movies we will extract. Then we will perform the intersect operation on McDormand. Okay. So this would be be a simple query. So first part, how to extract the movies of Cohen's. So for that we shall write select m dot title. So because we need a movie title only, from which table? So so it is actor and acts table. So from, so let us rename it. Yeah. So uh, we can utilize actor from actor A, comma, so in the acts table only we'll write it as double A. So where A dot, in order to link these two table is actor. So A dot actor is equal to A dot actor, and we must put the condition that A dot actor name is Dorman. Sorry, Cohen. So first we'll be extracting Cohen's. So this will return the movie titles acted by Cohen. Then we have to perform the intersect. So the keyword in SQL is intersect. So it is not the complete intersection. So the only keyword is intersect. So here we can write like this. So just change the name of the actor. A dot title from. So you can use the same aliases because the queries are different. Or if you want, you can change the aliases also. So where A dot actor is equal to A dot actor and A dot actor is equal to, so the actor name is here McDormand. Okay, so now what happened? So This will extract the Dormant's movie title, and this will extract the Cohen's movie title, and then finally the intersection will happen. So this will produce a result only if both have acted in a single movie. Okay. So next question we have, that is find the actor and director pairs where the director is younger than actor. So which means we need a mechanism to join the actor and the director table. So because only those two have contained the age, but how to link them? So in order to link them, we need all the four tables. So because director can be linked with only movie table, then movie can be linked with acts, and acts can be linked with actor. So which means we need all the four tables. So join all the four tables and then put a condition on D age. Okay, so let us quickly write that particular query. So select, we need a director, so that is D dot director, and actor we need, so A dot actor. So that is the select condition. So from, so we need all the four tables. So movie, let us call it as M, then actors, let us call it as A, then acts table, let us call it as AC, and then directors table, so let us call it as D. Where, so join all of them. So M dot title is equal to, so movie and acts can be joined use on based on title. So movie on this is AC dot title, and then acts and actor can be joined, so that is AC dot actor is equal to A dot actor. So this join the three tables, and then we need to join the director. So director can be joined on M dot director is equal to D dot director, right? So in order to join four tables, so we need a minimum of three conditions, so that we already have. Okay. So then is the condition that has been asked in the question, that is where director is younger than actor, so which means director age should be less than actor. So that condition, so we can add over here. And so where do we get the director's age? In the table D. So D dot D age should be less than actor, that is A dot A age. So that's the condition. So this query will extract the director and actor names who have satisfied this particular condition. So actor and director pairs where director is younger than an actor in that particular movie. So this is the simple SQL query. So we shall stop here for today's class. So you can put your attendance.